All right, now we're doing question 7, and it says, state and explain whether a neutron is a fundamental particle. A neutron is not a fundamental particle. It is composed of quarks. Quarks are the fundamental particle. Okay, we know we were just talking about how a neutron is what? Down, down, up. So that's the quark constituents of neutrons and indicating it's not fundamental. A proton in a stationary nucleus decays. Okay, state the 2 leptons that are produced by the decay. Oh, I like this question. Let's start with a proton decays. So what's it going to decay into? It's going to decay into a neutron. So it still is a nucleon, but it's not positively charged. So we got to balance this. Here's a charge of +1, here's a charge of 0. So we got to have a +1 charge. That's not a nucleon. That's our positron, right? That's our beta plus particle. That's a lepton. So we got a positron, which is the same thing as a beta plus particle. Same thing. And if you get a positron, the antiparticle of the electron, then you're going to get a neutrino to go along with it, an electron neutrino to be precise, but not an antineutrino. That goes with the beta minus decay, regular old electron decay. So those are the 2 leptons, neutrinos, and positrons. Part of the energy released by the decay is given to the 2 leptons. State 2 possible forms of the remainder of the released energy. So we've got a proton decays and the energy is given to the leptons, 2 possible forms of the remainder of the released energy. Well, it could be the kinetic energy of the rest of the nucleus, sort of going back the other way. So just like we talked about with the alpha decay, the alpha particle pushes off a sort of the analogy I use, like a swimmer pushing off of a wall. So the rest of the, sort of giant polonium or uranium atom, and you have a little stable alpha particle that says, I'd be better off on my own, more stable this way. So the alpha particle ejects, it's pushing off of this thing here. So it's going to send it with some kinetic energy that way. And so some of the released energy could be like kinetic energy of the rest of the atom. They already kind of say that, like there's going to be some energies in these things that are sort of, emitted. So they've got kinetic energy of the rest of the atom, and gamma radiation. So oftentimes there's, gamma photons that are produced in these nuclear reactions. This might be a good one to check the mark scheme on.